refraction is, so refraction through a glass slab. So this is a glass slab. Let us consider the thickness of this glass slab is T. Okay, ma? Thickness of the glass slab is T. So a ray of light is incident like this at an angle of incidence I. Okay. So this is my first medium, air is the first medium, glass is the second medium. Now light is entering from which medium to which medium? Light is entering from rarer medium to denser medium. That's all, no? Light is entering from rarer to denser medium. So therefore what happens to the speed of light? Reduces, no? When speed of light reduces, will it bend towards the normal or away from the normal? It will bend towards the normal. No? See here, if there is no glass slab, light should have traveled in this direction. No? If there is no glass slab, light will travel in this direction. But because there is a glass slab, it starts bending towards the normal. Okay, ma? So therefore, which is the angle of refraction here? This angle we can call it as angle of refraction. Okay. And then what is this angle called? This angle is called as angle of deviation dou. Because the angle between the original path and the refracted path, that is called as angle of deviation. No? So this much will be the angle of deviation. Okay. Now light ray is entering into glass. It is refracting towards the normal, bending towards the normal. And again it is reaching the second surface, no, again. First surface of the glass. This is the second surface of the glass. Now here I have to draw one more normal. No? One more normal. Now light is entering from which medium to which medium? Now light is entering from denser medium into rarer medium. So what happens to its velocity? Increases. When velocity increases, will it bend towards the normal or away from the normal? So it will bend away from the normal like this. Are you able to understand now? So let us call this angle as angle of incidence I. Clear, ma? Or you can call it as I1. Let us call this angle as R1. So if this is R1, this angle is also R1 only. No? Alternate angles, no? This angle, if it is R1, this angle also will be R1. And this angle, let us call it as angle of emergence E. Are you able to understand, ma? Angle of incidence, angle of emergence. The angle at which light is falling on the glass, the angle at which light is leaving the glass slab finally after two refractions. So at the point number 1, first refraction is taking place. At the point number 2, second refraction is taking place. Two refractions are there now. First here it is bending towards the normal and here it is bending away from the normal. Okay. Now if I apply Snell's law at the first interface, applying Snell's law at the first interface. Which is the first interface? This one. No? So at the first interface, if I apply the Snell's law, what is Snell's law? Sin I divided by sin R is equals to mu2 divided by mu. Okay, ma? Light is entering from air, no? So this will become the first medium whose refractive index is mu1. Okay, ma? Light is entering into second medium, no, ma? So this becomes my second medium whose refractive index is mu2. Okay. So therefore I can write, so sin I divided by sin R. R, let us call it as R1 or R, both are same here. Let us write it as R only. So sin I divided by sin R is equals to mu2 means refractive index of glass only, no? Mu1 means refractive index of air. So mu2 divided by mu1, let it be my first equation. Understood now? What we are doing, just we are applying the Snell's law, that's all. Sin I divided by sin R is equals to mu2 divided by mu1. Okay, fine. Now let us apply the same Snell's law at second interface. This is my second interface. No? So here also if I apply, so sin I divided by sin R is equals to mu2 divided by mu1. Now here can you say what is I, what is R, what is mu2, what is mu1? Come on, try to say. What is the angle of incidence here? Angle of incidence is R, no? This is the angle of incidence. Which is the angle of refraction? This is the angle of refraction. What is mu2? This is mu2. Mu1 will become mu2. If this is 8, this is also 8, no? This is mu1. This one is mu2. But mu2 will become mu1 here. Because now this is the first medium, no? This is the second medium. Okay? And mu1 will become mu2 here. Are you able to understand? So therefore substitute. Instead of sin I will write to sin R divided by sin R. Again sin R means sin E, angle of emergence. divided by mu 2 divided by mu 1. Mu 2 is nothing but mu 1. Mu 1 is nothing but mu 2. Are you able to understand? This is my second equation. Okay. Now here I have reciprocal, no, mu 2 by mu 1, mu 1 by mu 2. If you multiply both of them, then they will get cancelled with each other, and I will get 1 normal. So therefore let us write here. So therefore what I can write, so sin I divided by sin R multiplied by sin R divided by sin E is equals to mu 2 divided by mu 1 multiplied by mu 1 divided by mu 2. Okay. So this one and this one will get cancelled. This and this also will get cancelled. So I will get sin I divided by sin E is equal to 1. So therefore I will write sin I is equals to sin E. So therefore angle of incidence is equals to angle of emergence. So this is one important property in the case of in the case of glass slab whose edges they are parallel to each other. Okay. So this edge and this edge, they are parallel to each other. No? In that condition, angle of incidence and angle of emergence, they are always equal. Okay. So if light is falling at an angle of 30 degrees, it means finally light is leaving the glass slab at 30 degrees only. Okay, ma? So angle of incidence and angle of emergence both are equal. So this is very important property in the case of glass slab. మీరు ఏ యాంగిల్లో అయితే లైట్ ఇన్సిడెంట్ చేస్తారో ఫైనల్గా అదే యాంగిల్తో అది లీవ్ అవుతుంది. ఓకే. బట్ హియర్ దెర్ ఈస్ వన్ ప్రాబ్లమ్. వాట్ ఈస్ దట్ ప్రాబ్లమ్? ఇఫ్ దెర్ ఈస్ నో గ్లాస్ స్లాబ్, లైట్ షుడ్ హ్యావ్ ట్రావెల్డ్ ఇన్ దిస్ డైరెక్షన్. If there is no glass slab, light should have travelled in this direction. But finally it is leaving in this direction. So directions are same. But light ray has shifted backwards. No? Light ray has shifted backwards. Are you able to understand? Actually it should have travelled like this. But now it is travelling like this. So it has shifted by how much distance? It has shifted by this much distance backwards. Okay. And that distance I will write it as a capital D. That distance, a capital D, is called as lateral displacement. Lateral displacement. Okay, ma? Why we are calling it as a lateral displacement? Because light ray has shifted backwards. No? It has shifted backwards. So that displacement we can call it as lateral displacement of the glass slab. Are you able to understand, ma? Lateral displacement because of glass slab. Okay. Now I want to calculate this D value. I want to calculate what is the value of lateral displacement. Okay. So let us see how we can do this calculation. Completed up to here. So listen very, very carefully. So this is very important for your IPE examinations also. This derivation part is important. Okay. Now let us see. So one thing which we have proved is that angle of incidence and angle of emergence, they are equal. Second point which we have studied is that there is some lateral displacement in the light ray. It means light ray shifting backwards. Okay, when light passes through the glass slab, and that lateral displacement we are calling it as a D. Now D value I am supposed to calculate. So let us take some triangles now here. Let us name one triangle A, B, this point let us call it as C. Okay, ma? And let us call this one as already D is there, no? Let us call it as E. Okay. So therefore I will take a triangle ABC, then I will take triangle AEC. Two triangles I am taking. Okay. So first triangle I will take ABC. Triangle ABC. Okay. So in triangle ABC I will take a cos R. Cos R. Cos R. What is cos R? Cos theta formula. Cos theta formula, adjacent divided by hypotenuse. Which is the adjacent side here? Adjacent side is AB, no? AB is nothing but thickness of the glass slab, no? So right now. So thickness of the glass slab divided by hypotenuse. Hypotenuse is nothing but AC, no? So write AC. Are you able to understand how we are writing this one? So cos R is equals to T divided by AC. So therefore what is AC value? AC value is T divided by cos R. Let it be my first equation. Okay. Then I am taking triangle ACD. Triangle AC, not D, ACE. Then I am taking the second triangle. In this triangle, I will take sin dou. Sin theta I will take, sin dou. Sin dou opposite by hypotenuse. Which is the opposite side? This is the opposite side. So here 90 degrees is present, no? So this becomes the hypotenuse. Are you able to understand? So sin dou is equals to this distance is nothing but D, no? Lateral displacement, opposite side. So D divided by hypotenuse is nothing but AC, no? Hypotenuse is AC. Are you able to understand? Now AC already I have calculated, no? So take this AC and substitute here. Okay. If I substitute here, then let us see what I will get. Then sin dou is equals to D divided by T divided by cos R. Are you able to understand? I want D only, no? So therefore D is equals to, so T into sin dou divided by cos R. Okay, ma? What is meant by dou here? See, ma, dou value, can I write it as I minus R? Can I write? Dou value, can I write it as I minus R? Because if this is R value, I value, then this total is also I only, no, ma? If this is I, this total is also I. But I want only dou. Then from I value, we remove R value. So therefore, dou can be written as I minus R. Draw the figure very, very carefully. Clear? So therefore, T sin, instead of dou, I will write I minus R divided by cos R. So this is the equation to calculate the lateral displacement which is produced in the light ray. Okay. So light ray experiences this much amount of lateral displacement. Fine. So I have taken the help of two triangles, that's all. Why? Because in the formula, I want the thickness of the glass slab. Because I need the thickness, I will take cos here. Because in cos only, I will get adjacent side. And I want lateral displacement. In this triangle, lateral displacement is the opposite side. No? Because I want opposite side, I will take sine. Have you understood why I have taken cos in one condition, sine in one condition? Ma? So in the first triangle, I have taken cos. In the second triangle, I have taken sine. So that in the equation, I require these values. I require thickness of the glass slab. Okay. It means if thickness of the glass slab increases, lateral displacement also increases. Okay. If thickness of the glass slab is small, then lateral displacement will be small. Thickness is bigger, lateral displacement also will be bigger. So this is my equation. So T sin I minus R divided by cos R. Fine, Norma? Or you can call it as I1 minus R1 divided by cos R1 also. If you take this one as I1 and if you take this one as R1. Okay, that's it. So the next concept which we are studying is real depth and apparent depth. Let us see what is the meaning of this one. Sima. So this is a container in which water is present and here there is an object. Okay. So light from the object, for example, if it goes straight like this. Okay. Now will it suffer any deviation or not? When one light ray, many light rays travels from this object to light falls on this object and that light will be scattered in every direction. So consider this is one light ray. Okay, so it is falling perpendicular to the water surface. Now this light ray, will it suffer any deflection or not? Will it suffer any deviation from its original path or will it not suffer any deviation? It will suffer any deviation. It will not suffer any deviation. What is the reason? This is the normal also, no? This light ray becomes the normal also. So if you apply sin I divided by sin R is equals to mu2 divided by mu1, it will not suffer any refraction. Are you able to understand? Its speed increases because light is traveling from denser medium to rarer medium. No? Speed definitely increases, but it travels in a straight line like this. Are you able to understand? So it doesn't suffer any deviation when light falls at an angle of 90 degrees to the contact surface or to the interface which is separating first medium and second medium. Now in this condition, which is the first medium, which is the second medium? This becomes the first medium because light is entering from here. No? And which is the second medium? Air is the second medium. Are you able to understand? Okay. Now let us consider, we take one more light ray falling like this. Okay. Now here if I draw one more normal, then what is this angle called? This is angle of incidence. No? Okay. Now will it suffer any deviation or not? Now will it suffer any deviation or not? Definitely it suffers a deviation because this is a denser medium, this is a rarer medium. So light, what happens to the speed of light, increases or decreases? Increases because light is entering from denser to rarer medium. Speed increases. If a speed increases, what happens to the light? Will it bend towards the normal or away from the normal? It will bend away from the normal. So it will bend like this. Are you able to understand? So this angle, let us call it as angle of refraction or angle of incidence, angle of refraction. Okay. Now here there is an observer who is standing and he is observing this light. Okay, ma? Now to this observer, can he see this object or not? This observer, can he see this object or not? Huh? He cannot see. Why can't he see light rays reaching that person? No? Definitely he can see that object. Are you able to understand, ma? Light rays, from where this light ray is coming? From the object only. So why can't he see that object? Definitely he can see. Are you able to understand? So this person can definitely see this object. But the problem is that this person cannot see the object at its original position. He will see the image of the object to be present here. Okay, ma? So, is it straight only? Okay, ma? Okay. Still it is not straight. Still it is not straight. ఎన్నిసార్లు వేసినా తప్పు వస్తుంది ఎవరా? Okay. So, this is what he will see. Okay, ma? So, what is the meaning of this one, can you say? This person can definitely see this object. This person can see this object, but for this person it appears as if object is not present here. He will see object is present here. Why? Because this is the property of the image formation. This is what our brain assumes. So in which direction light is entering into your eye? Human brain assumes object is present in the same direction. That is the property of human brain. Are you able to understand, ma? Light is entering in this direction. So this person believes that object is present in the same direction. Okay. So therefore, what is this height? This height is called as real depth. Actual depth of the object inside the water. But that person is able to see this object at this position, no? So this height, what we call this height, let us write here only. This height we can call it as apparent depth. What is meant by apparent depth, ma? The depth seen by the observer is called as apparent depth. Actual depth is called as real depth. So that is the difference between real depth and apparent depth. Okay. So let us write some note points here. What are the note points we have to write? Note points are that the observer sees the object to be present in that direction in which light enters his eyes. Light enters his eyes. Are you able to understand, ma? So therefore this person believes that the actually object is present here. Okay, ma? And that point is called as image of this object here. So original depth of the object is called real depth, and the depth seen by the observer is called as apparent depth. Apparent means as seen by the observer. Are you able to understand? Okay. Now, Sima, if this is angle of incidence, then what is this angle? If this is the angle of incidence, what is this angle? This is also angle I only, no? Again, they are corresponding angles, alternate angles. Are you able to understand, ma? So this angle and this angle, they are alternate angles. Similarly, if this angle is angle R, what is this angle? This angle is also angle R only, and they are corresponding angles. These two are what kind of angles? Corresponding angles. Corresponding angles are equal. Alternate angles also, they are equal. Okay, ma? Now again apply the Snell's law. Applying Snell's law. Where at this point A. Snell's law at point A. Are you able to understand, ma? What is Snell's law? Sin I divided by sin R is equals to mu2 divided by mu1. And here which is mu2, which is mu1, ma? This is mu2. Air refractive index is mu2. Refractive index of water is mu1. Why? Because light is entering from water to air. ఎక్కడి నుంచి ఎక్కడికి వెళ్తుంది light? It is entering from water to air. So this is my first medium. This is my second medium. Okay, ma? So mu2 is nothing but a refractive index of air. Okay. Let us call it as mu air. Okay, ma? So divided by mu1 is refractive index of water. Are you able to understand? Okay. Now sin I, if you take this right angled triangle, how can you write sin I? So let this point be point, if this is point O, let it be point B. Are you able to understand? Sin I means opposite divided by hypotenuse. No? Opposite is nothing but AB, no ma? So AB divided by OA. This is my sin I value, no? Opposite divided by hypotenuse. Clear? Now sin R, sin R. So here this is the opposite side and this is the hypotenuse. Clear now? So again AB divided by AI. Clear now? So this is equals to mu air divided by mu water. Or just you can write mu 2 divided by mu 1. Okay, ma? And refractive index of air is 1. So refractive index of air is how much, ma? It is 1. So therefore you can write 1 by mu 1 also, or just you can write 1 by mu also. If a second medium is air. If second medium is air, definitely you can write 1 by mu, no? Because mu 2 is 1, refractive index of air is 1. Then if it is 1, this will become mu. So 1 by mu also you can write. Okay. Now AB and AB gets cancelled, no? So therefore I will write AI divided by OA. So this is equals to mu 2 divided by mu 1. This is what you can write. Or if second one is air, then you can write 1 by mu also. Second medium, if it is air, you can write 1 by mu. Okay, ma? So, Sima, if this point A, if it is very close to point B, now here we are taking some assumptions. So listen to the assumptions very carefully. If a point A is very close to point B, okay, then OA and OB, they will become almost the same, no? Are you able to understand what I am saying? I have taken point A here, no? If point A is very close to point B, then OA, OB, they will become almost equal, no? Will they become equal or not? Here definitely OA is greater than OB. But if this point is very, 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 very close, then OA and OB, they will become equal. Similarly, again if this point is very close to point B, then IA and IB, they will become equal. IA, IB, they will become equal. In which condition? When point A is very close to point B. So write that assumption. Clear, Nama? If A is very close to point B, then what I can write? I can write OA is equals to OB, almost equal. Similarly, IA is equals to IB. This is also almost equal. Are you able to understand? Clear now? So therefore, instead of IA, what I can write? I can write IB, no? And similarly, instead of OA, what I can write? OB. So substitute those values. Shall I write here? So if I substitute those values, instead of AI, I will write IB. And instead of OA, I will write OB. Is equals to mu 2 divided by mu 1. Or I can write 1 by mu if second medium is A. Okay, ma? Now can you say what is meant by IB, ma? IB, what is IB? Apparent depth, no? OB? Real depth. So write down. So AD divided by RD. Apparent depth divided by real depth is equals to mu 2 divided by mu 1, or you can write 1 by mu. Okay, ma? And if you take the reciprocal of them, then also you can write RD divided by AD is equals to mu 1 divided by mu 2 is equal to mu. So you can write like this also. Are you able to understand? That's all. So this is the concept of real depth and apparent depth. Fine. So what is the property of the vision? Observer always believes that light is present in that direction from which light rays are coming. So he doesn't understand that the object is here, but I am looking in this direction. This total concept he cannot understand. Okay, ma? Because human brain doesn't have that ability. We always believe that light object is present in that direction from which light is entering into our eyes. So therefore, the image of this object will be created here. Are you able to understand? For example, if you take a fish. If a fish is present here, but you are looking from the outside of the water, then for you it appears a fish is present here. Meeku fish ala kanipistundi? It always appears a bit higher than its original position. Actually it is present here. But for you it appears fish is present here. So if you take a bow and arrow and if you try to shoot a fish, you will shoot here. ఇక్కడ షూట్ చేస్తారు, బాణం ఇలా వెళ్ళిపోతుంది. మీరు 100 సార్లు షూట్ చేసినా ఒక బాణం కూడా తగలదు దానికి. సో వాట్ యూ హ్యావ్ టు డూ? If you are trying to hunt a fish with the help of a gun or with the help of a bow and arrow system, then always shoot below the fish. Fish kinda shoot cheyali meer. Are you able to understand? If you shoot by looking a bit below, then there is a possibility that the arrow goes and strike the fish. Because if this is the position of the fish, for you it appears fish is here. Are you able to understand? So that is the concept of real depth and apparent depth. So fish మీకు ఎక్కడ కనిపిస్తే దాన్ని షూట్ చేసినారు అనుకోండి, ఏమీ కాదు, దాని కింద షూట్ చేయాలి. Because actually fish is present here. Are you able to understand? That's it. And what is the final equations which we have derived? These are the final equations. RD divided by AD is equals to mu1 divided by mu2. And here mu1 always represents the medium from which light is entering. That is water in this condition. Mu2 represents the second medium into which light is entering. Air is the second medium here. Are you able to understand? First medium, this is the second medium. Then this is the equation. And if second medium is air, then mu2 will become 1. No? If mu2 becomes 1, refractive index of the glass I can take mu. So RD by AD you can write it as mu also. Fine. You should not be confused here now, because every time he may not give water and air only, he may give water and glass also, water and kerosene also, petrol and diesel also, anything he can give. So it is better you should remember this equation. Okay, that's it. Completed now up to here. Then we will write a relation. Apparent shift. Okay, what is meant by apparent shift? Actually object is present here now, but to this person object is appearing here. Okay, so this shift of this object is called as apparent shift. Okay, so therefore this distance is called as apparent shift. Okay, so how can I calculate apparent shift? Apparent shift is nothing but real depth minus apparent depth. From the total real depth, if you remove the apparent depth, then what is the remaining distance? That is called as apparent shift. Okay, now you can write either in the form of this mu1 by mu2, or you can write in the form of mu also. That is your wish. Okay, so therefore let us do this calculation. Okay, ma? So see. So RD, how I can write? I can write RD to be RD only. AD, how I can write, ma? AD can be written as RD into mu2 divided by mu1. Can I write like this? Okay, ma? If I take RD to this side, mu1, mu2 will go to that side, no? So instead of AD, I can write RD into mu1 divided by mu2 divided by mu1. So therefore apparent shift, ma, this one. So apparent shift is equals to RD, if I take common, then it is 1 minus mu2 divided by mu1. Okay, ma? So you can write like this, or you can, if you want to further simplify, RD into mu1 minus mu2 divided by mu1. You can write like this also. So this is the formula for apparent depth in terms of real depth. Sorry, apparent shift in terms of real depth. Are you able to understand? Okay. Okay, ma? Or if you want to write in terms of just mu only, then how you can write apparent shift is equals to RD minus, instead of AD I can write RD divided by mu. RD divided by mu. See, I am writing both the equations. Don't be confused. I am writing first in terms of mu1 by mu2, then I am writing in terms of mu also. So that whatever may be the condition, you should be able to answer. Fine. So again, if I take RD common, then it is 1 minus 1 by mu. Okay. Or if you want to further simplify, you can write mu minus 1 by mu also. Similarly, some more equations I will write. Now instead of RD, I can write AD into mu1 divided by mu2 minus AD. I can write like this also. Instead of RD, I can write AD into mu1 by mu2. Okay. Now here if I take AD common, then what I will get, mu1 minus mu2 divided by mu2. Or just you can write AD if you take common, then you can write mu1 by mu2 minus 1 also. Okay, so these are the equations in terms of mu1 by mu2. Now if I want to write equations in terms of mu, Then how I can write? I can write apparent depth is apparent shift this one, sorry. Apparent shift is equals to, okay ma? So instead of RD, I can write mu into AD minus AD. So therefore it is mu if I take common, sorry, AD if I take common, then it is mu minus 1. So these are the different equations of relation between RD, AD and AS, apparent shift. Fine now? So I am writing in terms of mu1 by mu2 also, I am writing equations in terms of mu also. So depending on the situation, you can use any one of them. So all this you are not supposed to remember. You are supposed to remember this relation first of all. RD by AD is equals to mu1 by mu2 and mu also if a second medium is A. This is exclusively for which condition? If second medium is what? Second medium is air. Then only you can use RD by AD is mu. So remember this one equation and remember this second equation. Apparent shift is equals to RD minus AD. Okay, and remaining equations you can derive according to these two equations. Fine ma? That's it. అర్థమవుతున్నాయి కదా ఎలా చేస్తున్నాము? Very simple concept. Just how we have derived again, just by applying the Snell's law, that's all. Snell's law. We have applied the Snell's law and we got this total calculation. Fine. That's the question ma. So this is a glass slab. Thickness of the glass slab is 20 centimeter. Below the glass slab there is a pin. A pin is present. And observer is looking from the top of the glass. 20 situations చూసింటారు కదా మీరు. So you can take this one as water also. This is a fish also. Anything. So this is a glass. Thickness of the glass slab is 20 centimeter. And observer is observing this pin. Then what is the position of this pin? Pin appears to be presented which position to the observer. Okay. So let us see. So this is the concept based on real depth and apparent depth only. No? Clear number? So what is the relation? So real depth divided by apparent depth is equals to mu1 divided by mu2. First relation. Second relation is apparent shift is equals to RD minus AD. Second relation. Okay. If you have not by hearted the equations. If you know the equations, then apparent shift is equals to RD into 1 minus 1 by mu. This is also there is one relation. And this is the relation in which condition I can use. This is the relation when air is the second medium. Here air is only the second medium. Are you able to understand? So definitely I can use this relation. So therefore apparent shift is equals to real depth is nothing but thickness of the glass slab. Thickness of the glass slab is 20. 1 minus 1 by mu means mu1 only. No? Mu means mu1, refractive index of the glass. Refractive index of the glass is how much? 1.5. Clear number? So this is 20 into 1.5 minus 1 divided by 1.5. So 20 into 0.5 divided by 1.5. So 0.51 are 0.513 are. So 20 by 3 centimeters. That is our answer. Are you able to understand? So what is meant by apparent shift? Apparent shift means what? This is the object, no? And image is created somewhere here. So what is this distance? This distance is nothing but apparent shift. Clear now? So apparent shift, how much I have calculated? 20 divided by 3. Then what is this distance? This distance is 20 minus 20 divided by 3. So how much? So 40 divided by 3. So this is the position of the pin as seen by the observer. Observer sees that inside the glass slab, pin is present at this much of height, 40 by 3. That is our answer. Have you understood, ma? See, ma, whatever assumptions we are doing here, everything you should remember. What is mu1? What is mu2? Which one we are taking as mu1? Light ray is entering from which medium to which medium? All this if you are clear, then problem solving will become very easy. Okay. If you are confused about a single point, then everything will be collapsed. So that is the problem with ray optics. Okay, ma? Sign conventions, which one is mu1, which one is mu2, what happens when light enters from rarer to denser, denser to rarer. Even any background lo meeku perfect ga undali. Then only you can do the problems. Otherwise always you will get a wrong answer. Fine? That's it. Given question, ma? So here there are 3 media which are present. First one is the glass of refractive index 1.5. Second one is water of refractive index 1.33. Third one is oil whose refractive index is 1.2. Okay. So below all this media, below this glass slab, there is a mark present on the bottom of this glass slab. So when an observer looks from the top of all these three media, what is the position of this mark? It means what is the apparent position of the mark that I want to calculate. How can I calculate? We have equation only for one medium, no? But here three are present. So what can I do? Very simple. See, because of glass, there will be some apparent shift. No? Because of glass, the position of the mark will rise a bit higher. Because of water also, there will be some apparent shift. And because of oil also, there will be some apparent shift. Okay. So therefore, total apparent shift is how much? Total apparent shift is nothing but apparent shift because of glass, apparent shift because of water, plus apparent shift because of oil. That's all. So you calculate the apparent shifts individually, add all of them, that will be the total apparent shift. That's all. Are you able to understand? This is the method in which we are supposed to do this problem. Fine. Very famous question asked many times in the previous examinations. So therefore, total apparent shift. So RD into 1 minus 1 by mu plus RD into 1 minus 1 by mu plus RD into 1 minus 1 by mu. Are you able to understand? So real depth means thickness of the glass is 10. 1 minus 1 by, its refractive index is 1.25. Clear number? Next, apparent depth of, real depth of water, 8 centimeter. 1 minus 1 by, its refractive index is 1.33. Plus, real depth of, that is thickness of oil, 3 into 1 minus 1 by 1.22. Okay. So do this total calculation, that will be the apparent shift because of all the three media which are present. Are you able to understand? No? Understood now how we are doing? Because of glass there will be some shift. Because of water also there will be some shift. Because of oil also there will be some shift. Add all the three of them, then you will get the total shift. Okay? Huh? Mottam kavali. Total I want.